right, specific heat. Specific heat is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. For water, that's 1 calorie per gram degree Celsius, or 4.18 joules per gram degree Celsius. That's actually the definition of a calorie. Different substances have their own value, and those values always stay the same. So you can look at them in a chart in the book. The formula for specific heat, or the formula, using specific heat is right here, which, since this is an older set of notes, it's not fixed. Those X's are just times signs, and normally I would write it without them. And Q stands for heat. C is your specific heat capacity, which, remember, you can find in a chart. M is the mass, which would be in grams. That triangle is the Greek letter delta. So that says delta T, which means change in temperature. So you're going to be subtracting the two temperatures that you have in the problem. So here's an example. How much heat is absorbed? So Q, heat, is our unknown. 88.0 grams, that's our mass. Water is heated from 5 degrees Celsius, so there's one temperature, and 37 degrees Celsius, there's our second temperature. So Q equals Cm delta T. Q is our unknown. We have M, and we have two temperatures in the equation. So what we're missing is C, but remember, C is a constant, so we can look it up in a chart. We know this is water, so it's in our notes. 1 calorie per gram degree Celsius. So now we have everything we need, so we just plug in. And remember, delta T, we have to subtract. So it's 32 degrees Celsius. We've got grams on the bottom, grams on the top, Celsius on the bottom, Celsius on the top, so those units cancel. The unit that we didn't cancel is calories, which is an acceptable unit for heat. We do the math and we get 2816. But when we look at our information, our original numbers were only allowed 2 significant figures. So we're going to round to 2,800 calories.